Great. Thanks, Chris. So hi, everyone. Thanks for coming. My name's Craig Savage. I, as he said, used to be a rocket scientist. I used to work for Raytheon in the US. I have had quite the journey. As you can possibly tell from my accent, I'm not originally from around here. And I've journeyed all around the US, around the world a couple of times. And I've gone from being a PhD and an MBA. And what I want to talk to you about tonight is some of the learnings I've had, because as you go through and learn technical skills, and you look at computers, and you look at code, and you look at everything else, and it's getting faster and bigger and better. And yet sometimes your actual speed getting things done doesn't change. Come in, please. Or not. So that was the inspiration for the title of my talk, which is Breaking the Bottleneck from Fast Programs to Fast Projects. So why I'm here is, first of all, just to try to share some of my experiences. I looked up and there were some cliches on the internet that, intelligence is learning from your mistakes, wisdom is learning from the mistakes of others, or there was one that was a little bit ruder, which is that wise men learn from others' mistakes and fools learn from their own. So it's my hope that what I'm able to tell you will come in useful to you, because it's been a big step in my learning in terms of industry, and I want to share it with you. I'm using things that are open source. That includes code, data, and programs. All this is going to be going up on GitHub. So you'll all have access to the data, and by all means you should go out and look at it, modify it, learn from it, kick it around, change it, go for your life. I'm going to have links to that at the end of the presentation, and this presentation itself will be uploaded to GitHub, and we're recording it now for display on YouTube. So I just want to look at a simple problem, which is I've got some data for median house prices in Boston from an R package. So again, freely available data. And I want to use it to demonstrate some of the challenges I've faced and then some of the ways I've worked around them. Now, before I tell you about why I did all this and my journey, let me tell you a little bit about myself. First of all, I like school. I've been educated in both technical fields and business. I have a PhD in electrical engineering, and then I have an MBA. I have over 10 years experience in industry. I was talking with someone about where I lived before that and realized I graduated 20 years ago, and that kind of hurts. I've worked in various industries, including defense, which is my kind of rocket science days. Worked in biomedical engineering. If you have heard about the Bionic Eye project in Australia, one of my proudest achievements is some of the code I wrote was used in the first implantee. I'm now in credit risk. I work for a bank. And sometimes people ask me what it's like selling my soul to go work for a bank, and I remember working on targeting systems. And I look at them and I smile. So while those seem like they have a very big differences and it's a big range, actually what they all have in common and what motivates me is I like to see things happen. I like to see things getting implemented. What I enjoyed at Raytheon was when I went on flight tests, watch stuff that I wrote run in real time, see the output, assess whether or not it was working or not. And by the way, if you do cutting edge systems, be prepared for it to not work, and then fix it. Patient trials. And then for credit risk, when I make a model and it goes live, billions of dollars get re-rated through stuff that I did. That's what I like. My goal is to have a measurable impact. So I'm not as concerned about academic pursuit, my own knowledge and curiosity, money. What I really want is to have an impact on the world. So if you look at it from a technical perspective, if I just start talking about coding, this is my journey with respect to coding. You start off writing things on the command line. This includes the kind of cliche, you print hello world, and the computer writes hello world. I started the same way people have started in computer science forever. Now, I still use this. I still type commands on the command line one at a time. I use it for things like proof of concept, to do a quick calculation, simple analysis. But there's problems with doing this that you'll run into very quickly when you start programming. and that is I can't reproduce something. If I do some analysis on the command line today and you ask me to do it again later, I'm kind of stuck. And it's not generalized. So if I want to do some calculation for, say, mortgage repayments, and I type it in once, and then I find out that actually interest rates have gone down, now what are my payments? I can't tell you. The next script is pretty easily, these days, leveraged from the first, that I take all that stuff I do on the command line and I copy it to a file. So now I have a record of what I typed in on the command line, and I can do it again. Now this becomes reproducible now, but I can't generalize it. So finally, you write functions. You take what you had written on the command line, you turn that into a script, and you turn that into a function so that rather than spitting out certain numbers, you can take in arbitrary numbers. And it's kind of amusing that I have my functions which become generalized here, and yet on the first line, that print statement is a function. Take something in and print it. So as a programmer, you should all know this. You learned this in school. That's not the focus of my talk. If you're a stakeholder, you should be expecting this from your programmers. And one of the things I want to cover is what does that mean for you? So I've got this sample problem, median house prices in Boston. We have some data. And I want to consider, well, should I use linear regression or a neural network to model this? Compare the performance. I have this indicator of mean squared error, and I want to use that to assess which is better, my neural network or my linear model. Now, if I'm starting a project, I want to know, well, what's expected of me? What should I be delivering? I'm going to need to recommend one, or potentially both, potentially neither. All the code that I write to support that needs to be delivered. I need to document the results technically so that someone else can reproduce it. I need to have slides summarizing the results. And let's say this is going to take 12 weeks for me to do this. So here's my generic project. I'm going to define the problem, get a list of the deliverables, the scope, and the timeline. Then I need to do it. So that means getting the data, writing the code, summarizing it. Then we need to make a decision. I send that up to management, make a report, discuss everything with them. And they say, yes, do A, do B. We either agree with your recommendation, Craig, or actually, based on what you've shown me, I'm going to decide something else. Maybe they have information that I don't. Once everything's decided, I'm going to write it all up, prepare the slides, and then I'll be done. And remember, for me, this is what motivates me, getting done, making the impact. And I look at my kind of sample problem here, and all of this is done, right? I have the problem statement. I'm approximating house prices. I know what the deliverables are, the code, a recommendation, technical document, slides. I'm at the point now of writing and testing the code. And so let's talk about what it would be like for me to do that. So first thing I recommend you do is do a Google search to see if anyone out there has solved something similar. As it happens, I found one. Now, this isn't a coincidence. I chose this problem because there are resources online. But still, in fact, there's a blog out there that includes the codes and the graphs. So this is great, but it's all a script. I wrote it into functions. There's a data dictionary for this supplied data. This is amazing from an industry perspective. It makes me feel like dancing, like no one's watching. You do not understand how rare it is to be given data with a data dictionary. My sample has no missing values. This tells me this is academic data, not industry data, and further makes me feel like this. I wrote up code to do this in about half a day. Half a day. I said this is going to be a 12-week project. I wrote this up in half a day. Just call me the wizard. I got this. The code runs in seconds. Seconds. Technology is my friend. Yep, life's good. Writing it up took about half an hour. 12 weeks, huh? I'll be done in 12 hours. Yeah, I'm kicking goals here. So, moving along. Let's take a quick survey. Everyone raise your hand. Everyone hands up. So, if you don't actually implement things, either through code or if you're an academic, if you're not publishing papers, if you're a tradesman and you don't actually fix things, but maybe you're a hobbyist, maybe you just do things for fun, or you're just here to learn, put your hand up. Okay, so those of you with your hand still up, I want to talk about what it takes for you to finish a project. So if you're an academic, what does it take for you to get a paper sent off to the journal? What does it take for you to write your batch of code and get it implemented? If you're a tradesman, if you go out and do the work, but it's not done until someone actually signs off on what you've done, if you need someone like that, if you can't just finalize work yourself, put your hand up. A few people are reversing the decisions here. Okay, so for those of you who need someone else to finalize your work, if it takes you less than a week to talk to the person who needs to finalize your work, put your hand. So those of you who are still, put your hands up high. Let's see them. There's a few over here. For me, I can talk to my boss anytime. I can do that within a day. Easy. Or you can put your hands down now. But the point is there's a few of you who are like that, who, like me, might be able to talk to your boss every day, but he doesn't have approval authority to implement something. To talk to his boss generally takes me about a fortnight to get on his calendar and just to have the meeting with him. From there, assuming he signs off on everything, my work would then go to an independent validation team who certify that, yes, Craig, what you've done is correct. Remember, I'm talking about high-impact things, right? If I'm talking about putting an implant in a person, I want someone else to say, yes, this is right. I don't want that whole responsibility myself, and it's just good governance practice. Now, to be fair, the validation team, my current organization, is pretty good. The time it takes them to check what I've done is directly dependent on how good my documentation to them is. If I just throw a bunch of code over the fence, it's going to take them a long time. If I give them code that they can use and reproduce what I've done, they can get done quickly. So I've written it up. I've talked to my manager, talked to the person above him who has the direction to say, right, this is good. Validation's got it. They've done. Well, let's say it takes them a day. The next level up, they meet quarterly. It can be 3 months before I can get a decision whether or not to implement. That's still within my organization, assuming they say, yes, that's it. Let's do this. There's a regulator. It goes outside the organization to an external regulator. They're external. They're the regulator. It can take as long as they like. So for purposes of this demonstration, I'm going back to my fortnight. I've done all my code. I'm dancing. Everything's great. 2 weeks go by until I get to talk to my manager to see whether or not we can go forward with this. Finally get to the meeting. He says, great work. Oh yeah, I do great work. This is fantastic. But then he says, I notice, I've read your document, and I see you're looking at measuring nitrous oxide content to estimate house prices. I don't know how we're going to measure that. Do you know what impact that has on the neural network? And I say, no. 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 All right, so I need to go and I need to take this variable out of the model and see what impact it has. All right, I can do that. Everything's functionalized, so I just changed what variables I'm including in the model. That's 10 lines of code. It takes 5 minutes. I rerun it, and then I need to go into my documentation. Where is my documentation? I go into my documentation, and I need to update all these numbers and all these graphs and this table of numbers. And that takes me about 15 minutes. And now I'm feeling kind of like this. That, yeah, I got it. I'm hanging out. It's cool to be a panda. Yep. And we look at what's going on with my project. And I've spent about 4 hours coding. Running the code's taken less than a minute. Documentation's taken an hour. But 4 weeks have gone by. Yep. That's good. So 4 weeks. I meet with my manager again. He says, great work. I'm like, yeah, that's right. 4 weeks. I'm still much less than 12. I got this. And unbeknownst to me, he's had 2 weeks of meetings, including one about how great big data is and how we need to use all the data available to us because big data is big and it's going to solve all of our problems. And he says, we need to put that nitrous oxide, we need to put that back in the model. And now I feel more like this, that you told me to take it out, now you want it back in, and I just can't deal. So in terms of implementing things, I'm back to square one. In terms of my work, this has taken less than a day. I spent about 5 hours coding. The code execution is nothing. The documentation is catching up with my code. And now we're halfway through the project. And I'm no closer to doing what I want. I'm no closer to getting the feeling of success, which is what motivates me to work in the first place. So here, I found that my bottleneck is in confirming the solution. I can present things, I can do all the technical work, but I can't get it across the line. And every time I miss, 2 more weeks go past. For those of you who said it was less, for those of you who can meet more regularly, OK, shrink the timeline. If any of you are more than 2 weeks, these times all get longer. The bottleneck's not my work. The bottleneck is the approval of my work. So to get around this, I'm using something called real-time feedback. I want to be able to change things dynamically, present the new options to management, and have them say, yes, that's good, that's what I want, let's go. So when someone says, remove this variable, what I actually hear is, I don't know what variables I want. Because if they're going to ask to remove one, next time they may ask to remove another one. Or as in this example, to put it back in, actually, never mind. And pretty much all models are going to have some tuning parameters. The person whose blog I'm using as a kind of template for this, Michi Ellis, if you're watching this, hi, I've never met this person, says, at least in my brief experience, testing again and again is the best solution since there is no guarantee that any of these rules will fit in your model best. He said that about configuring a neural network, which is one of the algorithms that I'm meant to employ in my little problem here. But even then, if I'm going to do some kind of prediction, I need to have training and test data. How do you split it? What percentage? If you go out and read the literature, some people have 50-50. Some people have more data to train on than to test. Some people have more data to test on than to train. Frequently, people think that mathematics with numbers, there's one way to do it. There's a right answer. Because they're used to, if x plus 1 is 4, then x equals 3. And you can check it. And 3 is the only number. But if I say I'm going to split my data 75-25, and you say, no, 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 it should be the other way, 25-75, there's no right or wrong here. Depends on your problem. Depends on what you want to solve. It depends on your solution. So let's look at what it means to have real-time feedback. So I want to use that in terms of my problem. That I have this data set. I want to use a neural network and a linear model. And I want to, where's my, I want to look at them both. So this browser where I first showed you the document, that's actually an app that I wrote in R using the package Shiny, where we have our data. Here's a summary of the data for this Boston set. So I've got a random number seed so I can replicate this. And then I have, well, there's this question of 75-25. Is that right? Is that wrong? Is that useful? Is that not? Well, maybe it's one of these things where I should have more training than test. Okay, I'll change that. Where's Chris? Chris. Hi. Do me a favor. Pick a number. 25. Excellent choice. So I have a random number seed that governs how I split things. Note when I change that, my test data changes. I have resplit the data based on a number that Chris has chosen. Because if I'm a manager and you show me something, I want to make sure you haven't picked things just in the right way, that your results look the way that you want them to. So to get around that, I give you control. You do it. I'm not going to choose the number, you choose the number. And it depends on your management, your audience, whether you say, what should my random number seed be, versus pick a number. Because if you say pick a number, you change it, and they see the data update, they know they're in control. Or at least they perceive they're in control. And by the way, if people perceive they're in control, they perceive that it's lower risk. For this reason, most people think that when they're driving a car, they're safer than flying in an airplane. All the data to the other way, be darned. Most people will think driving a car is safer, or they'll say, yeah, the data don't back that. I'm going to go with the data. If your manager thinks that way, stay with your manager. That's huge. So now I have this very basic thing. The other thing you should notice is appearances matter. So I have this rather nice technical thing. But this is a browser. All the tricks you use in browsers can be used to make this look different. You can go with the cyborg approach. So if you have branding, if you have color schemes, if you have whatever, rather than using some simple little default white and black and blue, put all that on your apps. Make them all look the same. Build it and make it yours. So I've changed around some numbers here. We can, you don't want nitrous oxide? Okay, let's take it out. It's gone now. Now that I've split the data, I can train my neural network, and I can train my linear models. And we can see that the mean squared error on the neural network is a lot lower. Yes. Go team. Now from the blog from Ishi, I hope I'm saying his name right, there are some things that you might want to configure for terms of testing your neural network. So if you don't know what these mean, don't worry. But again, the perception of control is here. If you want more nodes or fewer nodes in the separate layer, note that the data are updating. Even if you don't understand what's going on, or your manager doesn't understand what's going on, the ability to change this and watch the data update in real time is giving them the perception of control, which means there's the perception of lower risk, which means they're more likely to go along with what you say and implement. So you can say, OK, well, that's the training data. We go on to the test data. And the neural network's not looking as good for this, for all the things I've set. And again, you can say, well, that's because you've randomly initialized your neural network wrong. You're Craig, I know you. I know you don't like neural networks. I don't, by the way. You've picked a bad random number seed. Pick another number, Chris.
199.
199. You got it. So now, the neural network is performing better than the linear models. Good choice, Chris. And you can again say, well, let's reconfigure this differently. Maybe there's a way to make the neural network better than the linear model. And there is. We can increase some of these things and make it better. Again, these numbers, even though they're numbers in this highly technical neural network, you might think there's a right number. There isn't. Remember the quote. There are certain numbers that you need to set based on your problem, and only by testing again and again can you find them. I've just changed, what, 7 or 8 things? If I had to wait 2 weeks for each of those, the project would be over. I'd be late. So again, we used to have a 75% training set. Now we have a 29% training set. I had my document that it was using 75. I've made some changes. And now I might want to cross-validate things. And by that I mean, well, one of the things I should be delivering is not just a single number, but rather a distribution. So I want to go through this process 10 times and see if I get similar results. Now this is going to take a little while. So I have it set up that it doesn't start going until I click the button. And once I click the button, it says, right, here's an update. Yes, I am doing something. Did that just finish? Yeah. Did you see the progress bar? Your computer is faster than mine, Ken. Did the progress bar come up? Yeah? Very good. Right? So now this has come up. And this is just a distribution of the linear models and the neural networks. They both have an outlier. The median of the linear models is higher than the median of the neural network, but the worst case neural network is higher than the worst case of the linear models. So there's not just a, well, this one's lower, use it. If your manager says, well, this one's lower, use it, find a new job. So now I have the capability to go through this quickly, just as with the mortgage calculator, change the assumptions that go into it, look at what the potential impacts can be, and go forward from there. Now you may think to yourself, well, that's great, Craig, on your little 500-row, 14-variable problem. I see. But actually, my data set has 140 variables, and it's 5 million rows. And I can't get it running in real time. My data set is much larger than yours. A few things to that. First off, if you are going to be developing software for data that's that big and it's going to take a long time to run, you should be testing your software on a smaller piece of it, just to make sure you don't have bugs. Because if you have a typo and it's going to take you 6 hours to run it, you need to have it ready on the smaller data first. That same method of taking your smaller data to test your code, use it to test your engagement. Make sure you're producing the right graphs. Make sure you're producing the right numbers. Give them control about what all the random number seeds are so that you're not influencing it. Secondly, for the linear models, if you're using Microsoft ROpen, you can do this in real time. I've done it. 5 million rows take seconds to run, the linear models. You can do this. And finally, note that there's the distinction I'm trying to draw here is real time or not. If this took a week to run, or if this took an hour to run, it would have no net impact on my project timelines. It either works real time with my manager, or it doesn't. Because once I'm outside that meeting, I'm waiting 2 weeks. I always find it funny when I read stuff about optimizing code, and it's talk about running things from milliseconds to microseconds. And I think, well, I'd be happy with either. So long as it's running fast enough for me to discuss with my manager in one sitting, I'm happy. And if I need a progress bar to show that, yes, it is running, it'll take a minute, I'm happy. So, some takeaways from this. The presentation matters. The way it looks matters. The way your data are laid out matters. The way you control your data, all that matters. And the important thing is the perception of control, that you're not cherry-picking things to push your agenda, that what the results are fair or perceived as fair by people. It's going to take multiple times. If someone came back and said, well, that's great, but actually I want you to have different segments so that you don't have one model, but rather I want you to have several submodels. Well, that wasn't in the project description, but OK. And he may tell me, I want you to have a model for this and a model for that. But based on that first understanding, I'm not going to believe him. I'm going to build it so that it's adaptable, so that if he wants 2 models, and then when we get to the meeting he wants 3, I can configure it to do all of those on either the full data or a subset of the data so that I can get whether or not that's what he wants within the meeting. Do people here use agile software development? Right? Same basic idea. People don't know what they want. You build something and give it to them, and they say, well, that's close, but actually change this. Doing that with the engagement so you can get all the appropriate sign-offs is an important first step of my journey. But now I said, well, after we decide, I need to go write it all up. And I need the technical document and some high-level slides. And the technical document and the high-level slides are meant to be for different audiences. They have different information. It's not just you take your technical document and copy and paste it all into PowerPoint. One of them should be at a very high level, kind of rah, 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 we've made a decision. Let's go with this. And the other one should be enough so that a technical person can reproduce what you've done and verify it all. Remember I said for my journey, at my work, if I build a model, I need to send it off to an independent validation team. And they say, yes, we see what he's done. There's no mistakes there. That's good for governance, that's good for the organization, and it's good for me. Because if I've made some tragic mistake, I don't want all that on my head. Updating the documentation can be rather slow. If you're updating things and you miss an early number, then suddenly none of, so that training test, right? If I had missed that, if I had put 80% when I used 75, oops. And then generated all of the charts, and someone from validation picks it up and types in 75 just like my document says, and none of the charts match, that gets awkward. And you can say, no, I'm sorry, I'm sorry, it was going to be 75, but I made it 80 before I ran it, I'm sorry. Don't envy you. And then if something does go wrong, and if you're on the cutting edge, you will implement things that go wrong. It happens. Someone's going to come back and say, hey, this work, we're going to audit this. We need evidence that you did everything in your power to make sure this mistake didn't happen. And if you did the work, who do you think they're going to come to first? So having very good documentation is helpful, because if we submit a model, it goes off to the regulator, they sit on it for a while, then they come back with questions. They're probably going to come to me. And if I've been off working on something else, I need to go back to my document. It's in my best interest to have good documentation for myself. In addition to, when I give it to validation, they'll be able to validate it faster. If it gets validated faster, it gets implemented faster, which is what I want. So it's good both in a positive sense and in a covering yourself sense. So if I go back to my overview of a generic project, this is where I was, and I was stuck on decide. And if I could get the solution confirmed, then I was going to go off and document it. And heaven forbid, in the 2 weeks between meeting with my decision maker, that he's made the decision and he says, right, that's it, neural network. And I'm like, okay, great, neural network. And I go and I'm writing everything up for a neural network. And he said, and in the intervening 2 weeks, a neural network doesn't perform properly. And someone comes in and says, neural networks are bad, no more neural networks. And I go to him 2 weeks later with all of my documentation on neural networks, and he says, actually, I've changed my mind, let's use the linear models. That makes me a very angry panda. I don't want to be an angry panda. So what I'm going to do is I'm actually going to reverse these two. I'm going to do the documentation before meeting with management. Which is an odd thing. It took me a while. It's not obvious as to how you do this. But remember, the technical document is everything I've done and trying to make that as agnostic and decision independent as possible. As sciencey as I did step A, this was the result. I did step B, this was the result. Without getting into, and as you can see, A is better than B. To try to just lay it out exactly what you've done. Because A is better than B, so we're going to implement A. I'm going to leave for the summary document. Now, I've got a bit of a confession to make. Do you remember when I was talking about the document and how you'd have to go through and update all the values. And I said it took me about, what did I say? It took me about half an hour, I think. I didn't do that. I thought about going in and copying and pasting all the values, and I just didn't want to. And I knew the punchline was coming of, oh, and by the way, then he comes back and asks me to undo everything. And I certainly wasn't going to go back and undo everything, knowing it was coming. So I didn't actually change the document. I just made up that number. It struck me as reasonable. That's not the way I do documents anymore, because going in and pasting this 20.1935, I just don't want to do it. It takes me a lot less time to do that. In fact, this document's updated with 20.2 and 38 to use not 75% training, but 29% training. For technical documents, the insight comes of knowing that I want to have the training percent here. Whatever it's going to be, I'm going to put it there. The results of my data, I'm going to put here. The linear model, the results are here. Note I've taken out the nitrous oxide. I've structured this data so that whatever the results are, I'm going to put them there, and I'm going to try not to make any value judgments to say, oh, gee, this is high, because I don't know what my decision maker is going to choose. I don't know what updates are going to be made. I know there will be some, and whatever those numbers are, I will put them there. So rather than copying and pasting, I have it automatically going through to change the numbers and change the graphs for me. The original is here, 75% training data. Using this template, I've gone in and said, well, I know that I'm going to change them. When I do the discussion with my manager and all those numbers get decided, I'm putting them in. Done. This also means that at the end of the meeting, I can go to my manager and says, this is the document. Let's make sure that all the numbers match. Let's make sure that all the graphs that I've made during our informal discussions, which I'm not writing it all down, let's make sure all those things match what I'm sending in. And I want to get it right now before we have 2 weeks intervening for you to change your mind. Let's get it all done. Slides, however, are different. They're for a different audience. Where's my shiny? There it is. Slides are different. The slides I want to be rah, 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 this is the one we want. This is what we like. Does anyone have a strong opinion? I used to be a teacher. If no one answers, I'm going to call on someone. What should we do? So based on the information I've shown you, should we implement the neural network, implement the linear model, implement both in terms of some A/B testing, or implement neither?
Present both and give you a recommendation that then choose.
Let's upper management. Something like that. Anything else you'd like to say about it? Complete with typo. So now I want to build those slides. Slides have been created, and if I go over to my links, we can look at the parallel implementation of a neural network in a linear model with reasons of down arrow. That's it. Complete with typo. Facilitated by Ken, whose computer I'm using. Thanks, Ken. Note I've time-stamped it, so I know when this was done. We're going to implement both, and those will be the next steps. And supporting information are some of the graphs that I had in my presentation. So that's that one. Maybe, does anyone else have an opinion of one of these other ones? OK, let's say I like neural networks. NN are cool. Lower, median, MSE, complete with typo. Let's build those slides. Implementation of the neural network. Because NN are cool. Notice timestamped. It's a couple minutes later. The supporting information is going to be the same. The only thing that's going to change is what I'm going to put here. Actually, not even that. What I'm going to put here, what the takeaway from the meeting was, I need to have a way to input the reasons that I'm given. I'd eventually like to format it so it looks a bit nicer than this. But then all the supporting information is going to be the same. The information discussed is what was discussed. The decision out of it may change. But looking at my options, we have two models. There's only 4 options. Do A, do B, do both, do neither. There's not many slides here, and a lot of them, the supporting information is all going to be the same. So I prepared the title page and the first slide conclusion for all these options. Pick one. Because I need my answer to be dependent on, because I need my documentation to be supporting my answer, and I don't know what the answer is going to be, I prepared them all. So no matter what you pick, I'm ready for it. I just need to record why the decision has been made. So that's all using the R package of R Markdown. And what I've done is I've prepared all the documentation before the meeting. And it does take a little bit of practice to have that technical documentation not say, as we can clearly see, A is better than B, but to try to be as neutral about it as possible. You can be judgmental in the slides. This has some other advantages, like remembering the meeting outcomes. I don't need to take minutes. I know the tool will document everything for me. It allows for the confirmation during the meeting so that I can say, this is what we agreed, yes? This is the documentation, yes? Everything here is as we recorded. I've put the timestamp in there for audit purposes so that if anyone ever comes back to me and says, well, when did you make this decision? How do I know this is the right set? Well, because the timestamp there could match the timestamp in my technical documentation. Output. You can do this as HTML, as I've done here. You can make PDF, and you can make Word documents. So for your technical documentation, if you want to add some more stuff, if you want to add that A is better than B, or this was the decision, or this is my recommendation, output it in Word and change it. For the slides, you can output HTML or PDF. You can output PowerPoint. If anyone in here is from Microsoft, I can do Word for my document, but not PowerPoint for my slides. Fix that, please. So the final step of my journey is one of collaboration and continuous improvement, which I have called sharing. So all this was done using open source stuff. In R, included and sorted packages. I've read blogs. Data are provided. This was all free by people I've never met. It's not like I was calling in favors from people. All of this has been made freely available. This was organized by social media. This was on meetup.com. I shared it with my friends on Facebook. While everyone might talk about, cat videos and inane tweets, the power, the willingness, the capacity of the younger generation to share is phenomenal. Now, I had never done any of that. But this talk is being recorded. I plan to put it up on YouTube. I created a channel for this event because sharing is the last part of my journey that I'm telling you about today. I created a GitHub account. All the code will be made available for free, just as people made code available for free for me. So that's the end of kind of my journey. From learning to program and how I learned to program into the step of having real-time feedback. So I can do agile algorithm development, agile engagement, and some ways around that. Going down to knowledge management, how do I record meetings? How do I make sure things are properly minuted? How do I prepare documentation and ensure it's consistent with the last thing I've done, including the fact that some of that was done agilely? In an agile fashion. And then finally, just the ways of sharing everything, for making everything available to the public. But the conclusion is that in many cases, the bottleneck, what's preventing projects from running faster, isn't technical. It's about getting through all the governance steps. Some ways that can help with that is to just increase confidence in terms of making things look nice. Even just, oh, you change the inputs and the graphs moves. Oh my goodness, this is mind-blowing. By giving the decision maker control, or the perception of control, so that to them it's less risk, so things get implemented. For governments, it really helps to have all the documentation prepared beforehand. Writing it technically does take a little bit of practice. And for the slides, because you don't know what the end decision is going to be, because you don't know what the end inputs are going to be, you may need to have multiple ready. But if the bottleneck isn't technical, you have time. You can prepare them all. And then finally, whatever you do, consider sharing it, even if it's only internally. Thank you.